Hello everyone, in this video we'll be solving problem 88, merge sorted array. The problem statement is we are given two array of type integers nums1 and nums2. We need to merge them together in a sorted way, and instead of returning or creating a new variable and returning it, we need to update nums1. This nums1 will have few zeros at the end. In example number 1, we have nums1 as 1, 2, 3 and nums have 2, 5 and 6. If you notice, there are three numbers in nums2 and there are three zeros in nums1, which needs to be replaced by nums2. We have been given this m and n variable as well, where m suggests the total number of integers in nums1 and n suggests the total number of integers in n2 or nums2. We need to merge them and save it in nums1. Few constraints that are given to us are the nums1.length is equals to m plus n. The total number of m and n will be less than or equal to 200, and m plus n will be between 1 and 200. And values could range from negative 10 raised to power 9 to positive 10 raised to power 9. Let's switch to whiteboard and understand the problem statement a bit better before we start solving it. One option to solving this problem is to create a new array of type integers, use two-pointer approach, iterate through both n1 and n2 or nums1 and nums2, and add values to this new array on the fly. And once the iteration is complete, we'll save this value or replace n1 with output. Now with this approach, our time complexity will be O of n1.length and the space complexity will be O of n1.length, as we are creating this new array to save the merged sorted list. Although this solves the problem, but let's think about how we can avoid creating this new variable and directly update n1, which will improve our space complexity. To solve this problem, we'll still use the two-pointer approach, but instead of creating a new variable, we'll directly update it into nums1 or n1. Normally with two pointers, we start from the left-hand side of both the arrays and start iterating towards the right until we are done with the entire array. But here, if we approach with the same plan, all of the important numbers which we need to retain are on the left-hand side, and all of the ones that we need to ignore are on the right. So we'll end up writing some complex logic to retain these values until we are done with the iteration, because we never know what type of values are there in nums2 to make sure the output is in sorted form. So instead of iterating from left to right, we'll do the other way around and iterate from right to left. As we know, we can ignore these values. It will make things much easier. It is given to us that both of these arrays are in sorted order. So we don't have to worry about the sorting of the numbers within an individual array. We'll use three pointers. P1 will be pointing at the value in n1 or nums1 from where we need to start the iteration. It will not be the last number because there could be few zeros. P2 will be the last number in n2 or the value from which the numbers begin. V1 will be the corresponding value which P1 is pointing. V2 same for n2 or nums2, and T will be pointing to the position where the character needs to be placed in n1. So when we start the iteration, P1 should be pointing at 3 because that's the last or the highest number in the array. Its corresponding index is 2. P2 will be pointing at 6 as it is the highest. Its corresponding index is 2. V1 is n1 of P1. The value of n1 at index 2, which is 3. V2 is 6. Starting off, the value of T will be 5 or the last index in n1 array. As we are building a sorted array, we'll compare the value v1 and v2 and save the higher value in the array at position 5 or whatever T is pointing at. So 6 should be saved at this position. So my array would look something like this after this run, 1, 2, 3, 0, 0, 6. As we save v2, we'll decrement pointer p2, which will become 1. We'll save p1 as is and decrement t. So now t is 4. The v1 will be 3, v2 will now be 5. Between 3 and 5, 5 is higher, so we'll save 5 in index 4. So the output state would be, after this run, we'll decrement our pointers. So t will become 3, p1 will still be 2, p2 will be decremented to 0. Its corresponding values are 3 and 2. 3 is higher, so it will be saved in position 3. So my nums array would look something like this, and we'll decrement all of our pointers. So t will become 2, p1 will be decremented to 1, p2 will stay at 0. Now its corresponding values are 2 and 2. When both of the values are 2, we can save either of them. It doesn't really matter. Let's do the value at v1. So at this point, the array would be 1, 2, 2, 3, 5, 6. And now we'll decrement. So t will become 1, p1 will become 0, p2 will become 0. Corresponding values are 1 and 2. This one is higher, so it will be saved. So my output would be 1, 2, 2, 3, 5, 6. And last but not the least, we'll decrement everything. So my p2, because it was saved, will become -1. p1 will still be 0. p1 is 1. Because this p2 is -0, we'll ignore it. So this value 1 will be saved in index 0. So my output will be 1, 2, 2, 3, 5, 6. With this solution, our time complexity, it is O of nums1.length, and the space complexity is O of 1. Let me show you how we can implement this using C#. In this solution, I start by having 3 counters. One is the return array counter, or T, and then one being the nums1 counter and then nums2. Then I start the while loop until nums1 or nums2 are greater than or equal to 0. If both of the counters are greater than or equal to 0, which means both have some valid values left, so we'll check the values at each indexes. If nums1 is greater than nums2 at particular indexes, we'll save the nums1 value and decrement num1 counter. If this is not the case, then we'll save the num2 value and decrement num2 counter. Let's say if either of the two counters are -1, which means we have already iterated through all the elements in that array, then I'm checking if num1 counter have some value left. If yes, then I'm saving that into the nums1 array and decrementing num1 counter. If that's not the case, the only last possible case is num2 counter is greater than or equal to 0. So I'm doing the same thing but on nums2 array. At the end, I am decrementing the return array counter, which is pointing the position where the character should be saved. This code, when submitted on LeetCode, beats 100% of the submissions made so far in terms of time complexity, and in terms of space complexity or memory utilization, it beats nearly 49% of the submissions. Thank you for watching this video. I hope you were able to understand this explanation and the solution. The link to the source code is available in the description below. Feel free to check that out. If you have any questions, do not hesitate in reaching out to me, and I will see you in the next one. Thank you.